look at page 309 of your student journal. We're going to continue dealing with square root functions today. Tomorrow we're going to move on to cube root functions, which we're going to kind of approach them in the same way that we do today with square root functions. Yesterday, or at our last lesson on Friday, we talked about building tables to make square root functions or make the graphs of them, which we can definitely do. But just like y equals mx plus b, where you're dealing with linear functions and you're dealing with a pattern involved to graphing, there's also a pattern involved when graphing square root functions. Okay, and that stuff's listed on the bottom of page 309, and I'll reference back to this here in a minute. But if you look at page 310, I want to do some of these graphs together using patterns versus using a table. Okay, you can still use a table, but I want to make sure we get the patterns down, understand how different parts of our function are affecting our graph. So the first thing you need to do in this is I want you to draw in, we're going to start with number 4 on page 310. Now I want you to draw in your corner there, okay, designating the first quadrant. If you're not doing this, you're going to miss out on some stuff that you're going to be sorry that you missed out on here in a few minutes. Okay? And then in order to graph that, I want you to think back to the function y equals the root of x. Y equals square root of x. Okay? So if I were to use another grid right here, just think of my table x, my table y, or with the value of y, and the square root of x here. So if I'm using the parent function y equals root x, and if I were to graph that, what's the first perfect number you could put in for x there? Is 0. Okay? The square root of 0 is 0. What's the next perfect root you could put in? 1. The square root of 1 is 1. And then the next one?
4.
4. Root 4. 2. And then 9. Root 9. 3. And we could keep going, but let's say we end right there and we get the order pair 0, 0, 1, 1, 4, 2, 9, 3. Okay? And if I were to graph those points, they're not all going to fit on here, but we'll deal with the first quadrant. I'd have 0, 0. I'd have 1, 1. And 4, 2. And then 5, 6, 7, 8. I'm going to put another spot out here. There. Now 9 fits. Okay? 9, 3. Okay? That is called your parent function. Remember, you can't go negatives because you can't have the root of a negative, so it doesn't extend this way. We don't put an arrow down here. Just start there. That is this graph. These points right here are points that you are going to plot every single time you graph, if you're going to use patterns. Okay, so write those coordinates down. That way you don't have to remake the table. Those are your parent coordinates. They're the coordinates for your parent function. So I took those coordinates, I wrote them up there, just right above my instructions, because those are the coordinates that I'm going to use every time. So on this graph right here, I want you to plot those points. Just put points. Don't actually put a line. Just put those points. Okay, everyone got them? All right. So let's talk about what things do. Go ahead. Didn't you just sharpen a pencil? Unbelievable. Okay. Hey, let's make sure that we understand anytime something is with x, that means it's inside whatever it is with the x value. That means it is affecting the x value. That means you are dealing with a change of measurement on the x-axis. So in order to understand this, you have to realize that you have two different measuring sticks here. When you put together axes, you have an x-axis measuring horizontally, and you have a y-axis measuring vertically. Now this is how you will do a lot of your graphing in the future. I mean, you can use tables at any time you want, but it's a lot faster this way. This right here says, I am going to do something to the horizontal measurements here. Okay, I am going to change my horizontal measurements in some way. All right? Now, if you look back to this, this talks about when I'm multiplying by a value of x. This is f of a of x, which is kind of confusing, this mathese. But then they show you an example. It's like, hey, if you have the root of 3x. Okay? Well, everything is kind of backwards inside. It's like going into the backwards world when you're dealing with the value of x. When you say, hey, I'm multiplying by x, you'd think things would get bigger. However, it's actually shrinking by the reciprocal of that. And here where you think it might get smaller, it's actually stretching by a factor of that. Okay, so one thing that you have to remember when you're dealing with x, things inside with x, everything's backwards. It all is only with x, and the way we know it's with x is it's inside the radical in this case. In other cases, it might be inside parentheses with it. Okay, but you have to be able to recognize it's with x. So the first step is to recognize, hey, that 3 is with the x. It's going to affect this horizontally. Is that 2 with the x? It's as simple as looking at it, is it inside with x? No, it's not with x. If it's not with x, it's with y. Okay? Is that 3 with x? Is it inside with it? Yep. It's with x. If everything's backwards, we're not adding 3, we're actually, it's a shift. Yeah, it's going the opposite way. I mean, we are adding 3, but when we graph it, it's going to look different than a plus 3. Okay? Is this 1 with the x? No, it's outside. Is this -1/2, -1/2 with an x? Is that negative with x? Is that -2 with x? Is this 4 with the x? Okay. Is this negative with the x? Yes. That's important that you recognize that, because that is shifting, that's dealing with horizontal. Everything else is dealing vertically, which is with y. Okay, so this 3 is with x. This means that I am shrinking. It's actually called a horizontal. So with x means horizontal. Sorry about that. Shrink of 1/3. Now, it's not asking us to do that or describe that, but I'm telling you that's what it is. I'm trying to explain it to you. So, what does a horizontal shrink means? It means it is shrinking horizontally. It means your graph, rather than being spread out like this, is being pushed together. It's like you're taking it and you're squeezing it together. That means everything is compressing towards which axis? X or y? Towards the y-axis. Yeah. Now, when you compress something, like if I squeeze it together towards the y-axis, I'm changing my horizontal measure of it. That make a little sense? No? Not all? Okay. What I want you to do is talk with your neighbor about how this graph's going to look when you're done there. Okay? Don't graph it on a calculator or anything. Okay. Hey, let me tell you what happens now. Since most of you recognize, hey, you go towards the y-axis, this actually, I'm going to use this point because it's the easiest one to show it with. How far away from the y-axis is this? It's 9 units. If I shrink it 1/3, where will it be? 1/3 of 9 is 3. It changes the distance away from y by 3. And the way I'm going to show it, I'm just going to put a 3 here showing, hey, that was after my shift. This point moved 1/3 of the way away from y instead of 3 times away from y. Okay, that means this point, this one's tougher. This is 4 away. So now it would be, well, 4 divided by 3 is, or just, let's make it easy. 4 divided by 3 is just 4 divided by 3. What is that? It's 4/3, which is like 1 1/3, which is like right about there. This point moves to there. That point moves to there. This point is at 1. Where would it be? 1/3. How about the point that's at y already? Just stays. So your graph actually now does this. This is the graph. Okay, and I'm going to stop there because I haven't calculated any other points. Okay. What's the next perfect square? After 9, 16, 16 comma 4. 16, like if I were to graph that, what's 1/3 of 16? About. Yeah, about 5, right? 1/3 of 15 is 5, so it's 5 1/3. So if I were to go 1, 2, 3, 4, 5, okay, I'm going 5 1/3 when x is at 16. So 5 1/3. I mean, you're way out there. I mean, we're not going to be able to get that point on there. Okay, it's 5 1/3 away. Okay, we'd have to go 16 and then bunch it up there. Dude, you're shaking my table like crazy. Okay, I think you got it. Okay, well, let's try. I'm not going to do, actually, yeah, let's do this one. Let's try this one right here. And I'm going to tell you that we're going to need our axes to be a bit different this time, actually. Let's go ahead and let's put them right in the middle. That way we can see. Okay? First thing, let's plot our points. 0, 0, 1, 1, 4, 2. Got our 0, 0, our 1, 1, and our 4, 2. We don't get our 3, 9 on there. Our 9, 3. Remember, that's our parent function. Anyone know what a negative does there? It's got to change it horizontally. That would be the negative on the outside.
Does it mirror it onto over the y-axis?
Good. The negative mirrors it on the y-axis. It's a reflection over y-axis. Now, the way we know that is, remember, it has to change points horizontally. So for those of you that I heard say, hey, you flip it downward, well, if I were to move this point down, did I change it horizontally? I changed it vertically on that. So when I'm changing horizontally, I've got to move it here. So this one moves here. This one moves over here. So I like to put just the negative to show that. So by using the negative, I reflected it over this axis, the y-axis. Now the 2, is that affecting vertical or horizontal? Vertical. It's affecting up and down. Okay? The 2 is actually stretching. My bad again. It's a vertical. I always forget the words first. Vertical stretch. By a factor of 2. What are you stretching from? Like here you were stretching or shrinking towards y. If you're vertically stretching or shrinking, what are you stretching or shrinking from? You're pulling it away from, not y. Yeah, you're pulling it away from the x-axis. So this point that's 1 unit away will now be 2 units away, because we doubled it. This point that's 2 units away will now be 4 units away. I'm just going to show that with a 2. That way I kind of recognize what's done. So I started here, I reflected, and then when I doubled it. What's that? Now you got to think, what's this distance? 1. So when I double it, it would be 2. You're looking at the distance. So this distance is 2, so when I double it, it would be 4. Okay? And this point doesn't move. So my graph looks like that right there. Now you guys, you could build a table doing this if you wanted. The tables will work just fine. Just like we talked about the other day, I'm fine with you making tables, but if you can learn the patterns, it's so much faster. All right, let's try this one here. All right, so we always start with the x first and work our way inside outward. So we start with the 3. Tell your neighbor what the 3 is going to do. So is it dealing horizontal or vertical? It's horizontal, right? It's in there with x. Horizontal. It's not multiplying now, though. It's adding. Okay, so this is called a translation. It means a slide. So for those of you who are like, I don't know what translation means, make a note to yourself. That means slide. It's kind of the slang term for it. But we use translation. That's the math term. Horizontal translation. That means we are sliding our graph 3 units to which direction? Yeah, it's left. I mean, the plus 3 would make you think maybe right, but remember, it's backwards. So rather than plus 3, we actually go left 3. Now, in order to do that, we better have our original points first. Remember our original points, 0, 0, 1, 1, 4, 2. You should get sick of these points. And then from there, horizontal translation, left 3. This goes 1, 2, 3. This goes 1, 2, 3. This goes 1, 2, 3. My points are now where the 3's are after we do that part of our graph. Nothing out here. What's the minus 1 do? Is it vertical or horizontal? It's vertical, because it's not with the x, so that means it's with y. Vertical, it's subtracting and adding, so it's a translation. Am I going up or down? Is this one backwards? No, only the x stuff. So this one will go down 1. So that means from this point that you've already moved, you drop it down 1. From this point, you drop it down 1. From this point, this one actually becomes that same point right there. So that's what the minus 1 does. So that means if I connect all these 1s, I go from here to there to there. And I'm going to stop there because I haven't plotted any more points. That is my graph. Now technically, if you would have used 9, 3, if 9, 3 is over here somewhere, you could calculate that point. You actually move 9 back 3, you're at what? 6, and then you drop y down 1, you're at 2. So if I were to go 1, 2, 3, 4, 5, 6, 1, 2, that's actually another coordinate if you wanted to put it in there. Okay, everyone rate themselves 1 to 5 right now. 5, you think you're getting it. 1, you're struggling with it. Okay. The one thing we haven't talked about on all of these is domain and range. Here's what I want you to do on each one of these graphs. I want you to find your starting point. Put the coordinate of your starting point. Write down that coordinate. Okay, here hopefully you put 0, 0. Here you put 0, 0. Here you put -3, -1. That is your domain and range, or that's the beginning of your domain and range, always. Remember, x is domain, y is range. Domain, range. Domain, range. That is the beginning of them. All you have to do now is say domain is my x value at 0. Range is my y value at 0. Here, domain is my x value at 0. Range is my y value at 0. And on this one, my domain is my x value at -3. My range is my y value at -1. The last piece is just putting the correct symbol in between x and 0 and y and 0. X and 0, y and 0, and x -3 and y and -1. So remember, domain is x. This is your measuring stick. If you start at 0 on x, are you getting bigger or smaller? Your graph's increasing, so it's going this way on the positive x value side, so it's greater than or equal to. On y, if I start at 0 on this measuring stick, am I getting bigger or smaller? I'm going upwards, which is bigger values, so y is greater than or equal to 0. Tell your neighbor what should go in for the symbols on number 5 there. Okay, what should go in right here? Good, you go to 0 and you're getting smaller, so you're less than or equal to. Y?
Can I stand up?
Greater than or equal to. Can you stand up? What? Oh. All right, and here, x is starting at -3, you're getting bigger or smaller? Bigger. Y, you getting bigger or smaller? Bigger. Okay. There's our domain and range. On this last one, I want you to focus. Where could I have got that -3 and -1 from if I didn't have my graph? -3 and -1, where did it come from?
It's the opposite.
Everyone see it? Here's my -1. That's the y value of your vertex. Or the domain. Y value of the domain. We call that in math, we call that our k term. Thank you. We call that our k term right there. This right here that's the x value of the vertex. In math, we call that our h term. Now, notice it's opposite. Remember, it's backwards in there. So we have to take the opposite of that. What if there isn't any value in there, like on number 5? It's 0. Yeah, we're not adding or subtracting anything. What if there's nothing out here? It's 0. That's why we have 0, 0. On this one, we have 0, 0. Okay? Like if we were looking at this one, what would be the vertex? Or the starting point? Yeah, there's nothing in there. It'd be 0, 0. We'd start there. Where would we start on this one? 3, 0. Where would we start here?
Negative.
So for x, are we adding anything?
No.
Nope. Y, are we adding anything? Yeah. So this domain would be? X is? That's 0. Y is at 0. What's this going to do, this negative? Is it going to flip it down or flip it left?
Left.
It's going to flip it left. It's a horizontal flip, so it changes that sign. It flips the sign left. Okay? Y doesn't change. So this one, x is at 3. Y is at 0. Any flipping going on? Nope. So they just stay. Here, x is at 0, y is at 4. Any flipping? Tell your neighbor what tells you you're flipping. Negative symbols, yeah. Okay. So when I'm looking down here, am I going to be flipping this one?
Yes.
Yeah. Am I flipping it left, right, or up and down? I'm flipping it to the left. That means x would start at what point? What are we adding to x? 0. Starts at 0, and it flips to the left. Y starts at 0, and stays that direction. Is this one flipping? Yeah, it's flipping right here. Is it flipping vertically or horizontally? Vertically. So which sign changes? The X or Y one? Y. That one flips. And Y is at what point? Yeah, it's at -2. That's what we're subtracting. X is at 0. Okay, everyone write the domain and range for this one. Okay, x is at what? Almost. -4, it's backwards. Y is at 0. Did anything flip? Nope, so we just keep those symbols. I hope that clarifies domain and range a little bit. Should hopefully help out a bit on it. Alright, you guys think you got it? Okay, let's try the challenge problem. Number 11. Turn the page. Yeah! Woohoo! So pumped. Okay. Here, I'll tell you that you probably just want to use this quadrant. Okay? Get as far as you can on that problem. I'm hoping everyone at least put your starting points.
I'm just a tad confused. Just a tad. No, I'm completely confused.
You put your starting point? Hey, if you don't know where to start, start by doing something. You have to try something.
Would you do the 2 before doing like the X and Y?
A really good question. Do you do the 2 before you're dealing with the X and Y? You always start in the inside and work your way out. So you deal with a -3. So the first thing you want to figure out is what the 3 does. Second thing you want to figure out is what the 2 does. And the third thing you want to figure out is what the 1 does. It's almost, and this one's counting backwards. That's kind of weird. That's not meant like that. Okay? That plus 1, that minus 3, and that times 2, what do those things do? So what does the minus 3 do to our points? Is it horizontal or vertical? Horizontal. Is it a stretch, shrink, or translation? Or reflection, I guess. Translation. 3 right. It's kind of opposite. We'd think plus for going right, but it's 3 right. So we move this point 1, 2, 3. 1, 2, 3. 1, 2, 3. We move every point 3 right. 1, 2, 3. That's, yeah, I guess that one we kind of skipped because it's now off our graph. Okay, so I'm just going to erase that one. I'm not going to use it. Okay? What's the 2 do? Is it a stretch, shrink? Well, first, I guess vertical or horizontal? Vertical, it's outside. That means it's not with the X. It's vertical. Is it a stretch, shrink, translation, or reflection? It's a stretch. Okay, and we're stretching by a factor of? By a factor of 2. That means each of these points are stretching away from the x-axis by a factor of 2. This one's on it. So when I multiply a distance of 0 by 2, it's still 0. It stays right there. So I can now change that to a 2. This one is 1 unit from x. So now it needs to be, if it started at 1 unit and I'm doubling it, it needs to be at 2 units away. So now it's right there where that old point was. And this one that was 2 units away is now 4 units. Okay? So remember, we're just dealing with the 2's now. Our graph has moved from all the dots to the 3's and now to the 2's. And what's the plus 1 going to do? Is it vertical or horizontal?
Vertical.
Vertical. Is it a stretch, shrink, translation, or a reflection? Translation.
Up 1.
It's going plus 1, so it's up 1. All these points move up 1. That goes to there. All the 2's move up 1. And that is our graph now. Okay, you got some questions you can help me with?
How is it that you figure out how the translations work? Because I didn't know.
So if you're adding or subtracting, it's a translation. And so inside, it's always opposite. So where it says minus 3, we're actually moving on the positive end of the x-axis, 3 units. We're adding 3. And this one is plus 1. That one stays the same, but it's outside, so it's a vertical. It goes up 1 from that.
Why do we do like the 2 before the 1?
Because it's attached to the root. So
okay, so because they do everything like to do with x, then.
Yep, we move on. Yeah,
then
from
the 2 would still have to do with y since it's not with the x.
Correct.
Okay.
Yep. Okay. Hey, the last thing. We've already you guys notice it says describe the transformations. We did that while we graphed it. So your description's done. The last thing I want you to do, it doesn't tell you to, but I want you to list the domain and range of this. What is domain and what is range? Okay? All right, tell your neighbor what you got for domain and range.
X is greater than or equal to 3. Y is greater than or equal to 4.
All right, there we got it.
Oh, I didn't do that.
like how to do the domain range. Because like domain, like in a regular graph, like I think of it like a regular graph, it's always going up, so x is always like gonna get bigger. But like if it's like reflection, then it switches. It switches because it wouldn't be like the same.
So it switch your sign.
Yeah.
Yeah.
Switch the sign.